Good morning. Tom and I are going to talk to you about some new ways to use old metadata that'll hopefully open up paths for new ways to use new metadata. I think some of you might be wondering what two people from SiriusXM, a satellite radio company, are doing at a mostly video conference talking about metadata. For us, program-associated data or program descriptive text is an essential part of our service. It's things like artist, title, IDs, something we call action signals, timestamps, and a whole host of other things, including sports scores. And I hope the examples that we're sharing help you understand how you can apply the same things to traditional or streaming sports, or esports even, and from there open up a whole other world of possibility. And I think familiar to some of you, we've had a routing problem. Our legacy environment, AES67, is AES3 TDM routed. Metadata is unicast vanilla UDP that goes through a proxy server configured as an XY router. This has created a management and troubleshooting headache. Different paths, different tools, different techniques, different ways of troubleshooting and understanding what's going on. We've also had a synchronization problem. Metadata receives an NTP timestamp at the source, goes unchanged through the router, and arrives at the destination. However, the audio receives its PTP timestamp at approximately the same time, but when it reaches the router, it goes through a de-encapsulator that discards the timestamp. TDM routes the audio and re-encapsulate, inserting a new timestamp that's unrelated to the original. So when the audio arrives at its destination, it's impossible to accurately correlate the two because the timestamps have been changed. So in about 2022, 2023, we started exploring other metadata transport options to help unify our routing environment. We looked at the existing standards, -40, -31 with the non-PCM flag, and even TTML. We also looked at open source options like message brokers and proprietary options. All of these had problems. They added unnecessary overhead and complexity. They used the wrong clock rate, which we'll talk more about in a minute. We're just inappropriate for the application. We're not going to stick generic metadata into captions. We're just plain messy. So we set about setting some requirements for our new environment. We decided that audio and metadata have to have the same precision to their timestamps. No more NTP for metadata and PTP for audio. We have to use the same tools and techniques to transport audio and metadata. We needed to improve the operability, the monitorability, and the maintainability of the systems. Our product is constantly evolving, so metadata transport needs to be flexible to change along with it. We didn't want to have to go back through standardization or back to our vendor partners for recoding things. Lastly, the metadata transport needs to be independent of video constraints. Whether it's because we're pairing the metadata with audio or the metadata is independent of a audio or video essence. We didn't want to be tied to things like ancillary data structures with having to figure out lines and DIDs and SDIDs. And we didn't want to have to convert between a 48 kilohertz audio clock and a video frame rate at 30 or 60 frames a second, or a 90 kilohertz clock. Anytime you go through clock rate conversions, you introduce inaccuracies, which causes problems with synchronizing media. Fortunately, at the beginning of this year, 2110-41, the FAST Metadata Framework, completed standardization. It introduced user-defined metadata in RTP to the 2110 suite of protocols. It's low overhead. If it works for your needs, you can include more than one data item package in a packet. You can classify your metadata into data item types to define the characteristics of your flows. You can use any appropriate clock rate, whether it's tied to a related audio or video essence, or it's specific to that metadata, you are limited to the standard DDP size limit. However, you can segment your media using what's called Annex A, simple object segmentation method. Taking a look at the fast metadata packet, you'll notice that the first 3 words are the same as other 2110 flows. The 4th word gives the data item package header, data item type, a k-bit, and the data item length. And that's followed by the data item contents that continue until the next data item package or the end of the packet. So how do you define your data item types? We identified 3 characteristics that help guide you in choosing this. Is your metadata sent with the same pace? Camera positioning metadata is probably sent once a frame, but an ID that goes along with it might only be sent once a second. Is it processed the same? SADM audio data is not going to go through the same transformations that captions are going to go through. And is it the same consumer? Is your video encoder also getting your sports scores? If you answer yes to any one of those 3, you probably have the same data item type. So what data item types did we define? We started with our existing metadata billboard format using that same XML in -41. We learned some lessons from doing that format that we're going to apply to other things that we do. And we're also going to add a more precise and accurate timestamp to the payload. However, we did identify that we had commercial triggers and other program structure signaling in the billboard payload. And those are used differently, paced differently, consumed differently. So those don't really fit in the billboard. So we're extracting that into a separate -41 flow using SCUDY 104 triggers. However, we're going to use JSON to encode the triggers in a readable and idiomatic way. We're not going to include the MPEG-2 specific fields. Those can be reconstituted just from the data structures that exist. We're going to be cross-compatible with strict SCUDY 104 implementations, either in TCP or in VANC. And we're going to use the UTC timestamp, not that 90 kilohertz clock, to avoid that inaccuracy. So what do we gain by using -41 and SCUDY 104? We start ourselves on a path to a flexible, observable future. We're taking the best parts of SCUDY 35 and 104 and our legacy billboard format and decoupling them from the transport constraints they were built around. We stop defaulting to legacy approaches and find innovative ways to use metadata. We create a path towards a software-centric future that's efficient and dynamic. Taking a look at our billboard message, you'll notice we kind of over-optimized on the attribute names, but you can pick out the artist and title, the duration, and a timestamp. Note that we also include more than one cue at a time so that we can build a look ahead for what's coming up in our downstream systems. The SCUDY 104 JSON should look fairly familiar. It looks mostly like the data structures included in the standards document. We support multiple and single operation messages. You can see the timestamp we added microseconds to it. We're using the time signal request workflow recommended by the latest versions of the SCUDY 35 standard. Here, we're inserting a segmentation descriptor. We can support multiple UPIDs to identify the upstream systems and any other content IDs that we need to include. And this is a distributor placement opportunity. Start message, there's obviously a corresponding stop at the end of a break. All the fields that are necessary for conversion to SCUDY 35, if we ever need to do that, are there.
And with any standard, there's always going to be some limitations, and there are going to be some things that perhaps didn't go right the first time. I think one of the things that we discovered, I think some others have discovered some similar things along the way, but the lack of in-band segmentation signaling is something that we found would have been helpful. Having the data item type always be so prescriptive. It has to be a certain way. Wasn't ideal. Ultimately, there's sort of, as Michael's referred to, it's a gentleman's agreement. There's no way to detect or enforce it. And, if you, let's say, and this is where you get into like the implementation of orchestration systems and things that perhaps you don't want to just spin up multicasts for every single situation you have. So having a pipe that's sort of available already to have that metadata flow through and let it be more dynamic would be, perhaps better. The other problem is that you run into, if you're sharing, let's just say in this case, 41 flows between different organizations, you're really not aware of what's being sent to you. It's a little bit squishy. So, along with that, certainly there's some opportunities we'll talk about in a second to revisit those types of things. I think additionally, we've talked about this too, is there's about, 4 million data types that are possible. And so, in terms of efficiency of how you, build these standards and how you use them, there's certainly a time and a place when you're going to want to be a little bit more truncated. And do we really need 4 million data types? I don't know that that's necessary. And we probably the issue, and we don't know for sure, but, you would have had space for a segmentation bit in theory. So that leads me to another thing, which is, FMX took about 6 years to publication at roughly. It might be off a bit on that, but, along the way, there's definitely some institutional knowledge that's been lost. But taking a step back, even just the process of something what I believe and we believe is super important for this industry, to sort of like to think about metadata in a very different way. It's going to open up doors to a lot of different potential workflows, whether they be production oriented, operations oriented, or consumer facing. And to decouple from that sort of bank that, the video side of things and to be more efficient, certainly. With that, I came across in sort of my research on this, there was actually an interesting thing that was happening in the DICOM world. And DICOM comes from the healthcare industry. And so, your medical imaging. There were people who were actually looking to use and leverage 2110. I don't know if anybody's familiar with this or more familiar than myself, but what I discovered is that they were actually using 2110 and setting aside and waiting for Dash 41 for FMX to be available in 2019. So here we are, and, I think it's very interesting that, there are other industries that are looking to leverage all this good work that's been done. But then you start to ask yourself, well, why didn't these things kind of come along faster? And I think to some degree, it is a little bit of the pressures that vendors and users need to put on each other. Users have to have creativity and say, we want these things, and vendors have to then respond. But certainly I'd like to see a little more, leading by example and creativity personally in this type of world. So I think, additionally, in terms of some of the issues we discovered, the Annex A length error is being addressed. That leads me to think there are potentially some ways that maybe we need to validate some things before publication a little bit sooner. The error was discovered pretty close to showtime for some implementers of SADM as one example. And, I think maybe there's a better way to kick the tires on some of these things that we should be talking about in this industry. So, getting back to the segmentation bit for one moment, I'm going to hand it over to Michael, is you have to wonder, was there a good reason not to prioritize that segmentation bit? And what's the historical record of that? And so, Michael,
so
solutions.
Architecture decision records are a lightweight, widely accepted in the software industry tool to combat institutional knowledge loss. They are a concise log of the decisions and the context that they're made in. They help strengthen the consensus around those decisions since you have a document to rally around. And you can remind stakeholders of past decisions that have been made, where they ultimately reduce the time spent on design work, even if you have to spend a little bit of time creating an ADR. They help you onboard new participants, and they really help fight that last-minute relitigation of decisions you've made earlier in a project.
So, as getting back to some of the markers and some of the, ways that we can use this metadata and that are being used now, there some things have been discovered as well, which are synchronization issues. And, I think there's sort of this general approach that, RTP and PTP, it's solved all the world's problems. And it's great. It's super helpful. But at the same time, when you start to look at more advanced workflows where you're going to be taking a piece of media and you're going to be processing it at various points in the signal chain, and then you have correlated metadata that also needs to flow through. Well, if that metadata is referencing a particular frame of media, and then that media gets processed, it could be loudness processing, it could be up-down cross-conversion, it could be frame syncs, it could be a delay for, somewhere in the signal chain. Your correlation's lost without preserving origination timestamps or actually the point at which these flows were distributed concurrently. So, I think that what we've realized is that you have to then have provisions and ways to retime that. And it becomes an interesting question. Are you retiming it at the metadata side, or are you retiming it on the media itself? And I think there's different reasons or different use cases why you would do that. But then it's actually interesting in the 104 domain that you would actually have to understand the payload. So whatever you're going to be retiming with, it actually has to go and get inside of the payload. It's not simply good enough to be addressing it on the RTP side. So the header timing and the metadata flows are, they're not directly correlated to the media frames. And so that, that latency and legacy systems retiming, that could be a problem. So, there's a lot of talk and work that's been done on this front in timing planes. And I want to just call it out for a moment because it is part and parcel of the problems we're trying to solve. And there are people doing good work to solve this. And maybe it's a little bit more of somewhat of a call to action to some degree. But, as noted before, the moment that you are diverging and making a change in your timing domain, you have to make a modification somewhere, or else everything's going to be out of whack. And I think about some workflows I've been a part of in the past, like in sports, for example, when you're dealing with instant replay officiating. The historical record of a sport and what happened at a moment in time really is important. And we can muck that up with our technology. Like if you in a truck have a frame sync that's inserting a frame of delay, and you're none the wiser as a downstream consumer of that information, of that media, there's no way that you're going to know exactly what happened, when somebody goes and touches a base, or, there's a tag up on a play, or did they make the basket in time? So those things, like, we sort of assume that they're all time synchronous, but in reality, there are things that can happen behind the scenes that aren't. There should be ways that we're tracking that and creating more of an audit trail of the timing information. And I think that kind of leads into the future opportunities for metadata. So truing up the timing plane variations, I think potentially keeping that audit trail. Dash 41 is something we've looked at as a way that potentially you could know at every processing device in a signal chain exactly when something happened and what happened. Additionally, what's very interesting too is you could actually annotate or have the device processing function be noted and carried, so you could know exactly what happened and when it happened. And why do you want that? I mean, that sounds, it sounds maybe like overkill. Well, sometimes it's just enabling troubleshooting, right? You might want to be able to have a sense of, something went horrifically wrong in a production, right? And you want to be able to kind of go back and look at your operations team and say, well, who messed that up? Where did it get messed up? Was it a third-party provider that sent us something that got mucked up? And so there's definitely some opportunities there, I think. In terms of production, it kind of gets back to automation. I think that there's a ton of metadata. We don't exploit metadata enough, whether it be your camera data, positioning. It's a center field camera. It's what have you. I think that those are all really important, but then there's also this whole rich set of metadata in sports in particular that's becoming more and more viable for people to access for the purposes of automating productions. And so when you understand the volumetric space, you could drive innovation in that regard as well. And it's not necessarily that Dash 41 itself would be a proper carrier for that. I think there are limitations, and we should look at that. But when you start to think about the things that go on in esport and in traditional sports, there's just a ton of information that can be used for automating productions and also for a consumer. I think there's another element here, which is manual logging of various events. So an operator is observing something happening in real time. They're watching the feed, they're monitoring it, and they see an error. They see macro blocking, whatever the case may be. You could federate the information from both your telemetry systems and the manually inserted event. And that event could be for anything. I mean, it could be for an anomaly, or it could be for something that's going to hint to a highlight that, somebody is interested in capturing in a post-production. I think that those things could be carried more real time, and they'd be more interesting in that case. So we talked a little bit about RTP. It's possible that maybe it's not the best long-term approach for all situations. Case in point, when you have large sets of data, maybe you need to distill it down, but perhaps there's a way that you can blend these things. So I think that there's definitely some things that we don't require, the same type of transport, the timing and sizing of packets to be the same as media. And, there's definitely some other constraints like, once again, I mentioned earlier, sort of decoupling or not being constrained by the legacy of the bank, for example. So I think, to kind of hit on the conclusions and recommendations here, we'd like to, divide the metadata flows based on, as Michael noted earlier, the precision, the packet pacing, and, really what does the media need? Like, we got to think more in terms of what are the actual workflows. And I think that sometimes metadata kind of gets pushed to the side. It's sort of an afterthought. And I think that we all need to embrace it a little bit more and think creatively. Kind of getting back to my point about vendors and users. It's a continual struggle where vendors aren't going to build things until users tell them, but users aren't necessarily thinking as creatively about metadata. But now we have vehicles to do this in a more time correlated way that wasn't as apparent before. And to Michael's point earlier, it's more observable so that you can now integrate that into your operational teams. So now everybody can sort of be leveraging this information throughout workflows. So leveraging, SCTE 104, decoupling from the bank, we are very bullish on that. Certainly, solving for timing planes. I think it's one of those, it's its own conversation that people have been pushing forward. But I think that we're going to be very limited if we don't solve that soon. 41, maybe it's not the best end state, but it's a great start. We're going to be using it and doing some cool things with it. And, as noted before, we definitely think that there's some gaps in the standards process. ADRs are a great idea. I mean, having an understanding of why something happens, it speed up the process. I mean, how many times do people sort of relitigate things because they don't kind of go back to why a decision was made? Now, I'm just not talking about in a standards process. I talk about in organizations as a whole. It's really important to kind of to document those things and understand it later on when somebody goes in and questions, well, why did you do it that way? So yeah, I think that, probably the thing that I would really like to hear more from, whether in this form or otherwise is what are you all doing with metadata? Where do you all see this heading? I think that's a really important thing. Michael, do you have any thoughts or closing comments or?
Yeah, I just want to say that this has been an incredible team effort to get this done as quickly as we have. And we're just a small part of this, and we're indebted to the team at SiriusXM, Scott Schmidt, Matt Petronelli, Thom Mormon, Ryan Meyer, and at our vendor partners too.
Cool. Any questions?
So I just love it. Thank you guys for doing that part of the artist in civil production. We do with the data, and that's the direction we're going. We're going to 41, but also first, thanks everyone here on the always going. Thanks him for pushing 21. But the key here is,
Michael, check. There you go.
Great.
But I think the key here is it's not 41, it's 42. That's when 42 is where you're going to define what 41 is going to be. Because to be honest, 41 is a black hole. It could be anything you want.
Anything, yeah.
It's KLV, right? Key, length, and body. So with that, you can do whatever, right? So 42, and that's where I invite everyone to be part of the committee on the 42, is where you define what 41 is going to be, right? So in your case, you're bringing 40 into 41. But in our case, we're bringing a lot of metadata from virtual action, which is what you mentioned, camera, lens, camera tracking, whatever you want. But that becomes a big problem when you have to manage all that data. I think in this case, the standard should be on the direction of what port you're going to use, or IP range. I don't think IP range is a good idea, but what port you're going to use is the main one. On the other side, the metadata on 42 is where you define what you do on 41. So that's one, but it's just to clarify. But I have a question for you on the synchronization, on the RTP, when you say it might not be the best solution. Can you explain why?
Yeah, sorry, I didn't hear the one.
On the RTP, you mentioned that the RTP might not be the best solution.
Yeah, no, I mean, I think it was just, so it's not that you throw out RTP. It's not, I don't want to misrepresent it. I think it's that ultimately, what happens is, for example, in those Scuddy markers, the moment that you change something in the media, that media and its RTP, cool, great. But you're not able, like a downstream system, an encoding system that's consuming that media plus that metadata, it's going to throw away that RTP header. It's not interested in what's in it. It's interested in what's inside the payload. And I think there's an assumption that's made with 2110, and maybe that's more of what I'm trying to call attention to. There's an assumption that it all just kind of magically lines up, and it doesn't.
There's also, if you look across an enterprise or across an end-to-end workflow, a message broker might be more appropriate for that particular workflow than a stream.
Okay. In our case, at least for camera or camera tracking metadata, we already, because it's going to happen, you have to do offsets on everything what's going on at the same time. So we thought about that, but also embedding inside the metadata your RTP time. So that's part, because the package could be really long. And the first part is what matters, really. And then you create the offset, right? And then you synchronize everything at the end of the line, basically. So I don't think RTP is the wrong solution. I think you can be more accurate than RTP. It's just how you manage those offsets from delta 0 to delta X.
Yeah, we're actually, in both our billboard format and in the Scuddy 104 format, we're using the payload timestamp for actual actions that happen with the product. The RTP timestamp is there just to understand what's going on in flight.
Right. Just to clarify, in virtual production, there's so many parts playing at the same time that the offset is part of the system. So that, yeah.
Yeah, and I think you're right. There's so many different ways to approach solving the problem. I think the one thing maybe when I think of when I look at something like this is we should probably be talking more, and not just us, but the others.
Like you said, this is the beginning, and 42, I think that's the big discussion.
But that's right, because if we can, we can have a bunch of different ways to solve the problem, and then, once again, they're not going to all be compatible, and then, let's be honest, there's not a lot of looking peripherally that goes on. People don't really look at enough. What goes on in other industries, my point with the healthcare industry, I mean, what are they doing? They've got sensors and media that they're trying to federate for operating rooms, right? They've got fluoroscopy, they've got echocardiograms, they've got, these it's all video and it's metadata at the end of the day. We could all be comparing notes with each other and come up with better ways to federate telemetry, other metadata that's more production oriented, like you mentioned, but to do it in a way that makes sense, not the Wild West, this one, that one over here and there. So I think it's a great, be good to talk more.
Well, thank you, guys.
So a quick comment, if I could. I've been working in with the archive exchange format, which is the SMPTE standard for standardizing how you write data into data systems and data stores. And so one of the things we ran into really early on was exactly the problem that you're describing, which is you've got heterogeneous types of metadata, and you'd really like to know at least some of the decisions that came before, even if it's not the data that is today. And in the archiving world, that's called provenance metadata. It's basically the record of what happened before you got to where you are today. And so it sounds like, many of the very same concepts that we do in data archiving or in media archiving are kind of what you're talking about here, where not only are you talking about, keeping at least some of the key data points like timestamps or previous metadata versions before the updated version, wherever we can. How did we get to here today? The part of the discussion, it sounds like, needs to be, what do we need to save? How do we need to save it? And is it more than a rounding error on the essence content that it's applied to? In most cases, at least in archiving, we found that we could generalize those rules across all data types, not just media data types, but all data types. And with very few exceptions, the metadata, the extra metadata that is retained as part of that provenance chain is still a rounding error compared to the essence that you're carrying with it.
Yeah, no, I love it. And, I didn't want to go too deep into this topic before, but I think what you're calling upon is something that's sort of near and dear to me, is bridging that gap between live and file-based workflows and back out of file-based workflows into live. It's like, no, we hand it over here. And there's not enough consideration to what's an elegant way to tie these things together. Exactly. How do you map those things? And you're starting to see some of those like SADM and MXF and some of these other things that might be addressing aspects. But I think that very much you have to contemplate that when you start not only having access to the metadata, it's where do you put it? Don't throw it out. We should be exploiting every bit of metadata that's out there. And I call upon vendors to help us exploit more of that and to expose it to users, because I think that's when the imagination starts to wander a little bit, and you start to say, wait a second, I could solve that problem. I didn't know I could even make that available. For too long, we kind of sit around and don't actually know what's possible, because we accept what's already what's been. It's time with 2110 and all this to just forget all the legacy stuff. You've got this vehicle. It's not mature enough yet, but it's a good baseline. Build on that, but also solve some of these other workflow problems.
Talk about it as we're going along.
Sorry?
Let's at least talk about that as we're going along.
Yes.
Let's not make assumptions.
Yeah.
Great, thanks. Thank you very much to our esteemed speakers.